Hey guys, welcome back. We are going to try two more examples on how to find the max and or the min, if any, on a function. Okay, so in this case I said find the critical number or numbers and use the number to find the relative max or relative min. I don't need to tell you to find the critical number. That's the first thing that we do when we're looking for maxes and mins. So first thing I'm going to do is I'm going to take the derivative. The derivative of x to the third is 3x squared minus, now remember, 3 halves. Okay, some people are not going to see that. So x squared is 2x to the first. Okay, so 2 and 2 cancel. So this gives you 3x squared minus 3x. So that's your derivative. Okay, so we set the derivative equal to 0, and we're going to factor, because we always factor when we have squares. So we're going to take out a 3, we're going to take out an x, and you're going to be left with x minus 1. So my critical numbers, okay, is going to be x equals 0, x equals 1. Great, because that's where the derivative is equal to 0. Now we're going to put a number line, and we're going to put the critical numbers down, and then we are going to take the derivative. We're going to place the derivative there. And then what we're going to do is we're going to pick a number here, here, and here, okay? So I'm going to pick the number 2. So what's f prime of 2? If you remember from the last videos, I don't care about the actual value. I only care about the sign. So f prime of 2, I'm going to have to go back to f prime. I can use this or I can use this. I love using the factored form, okay? So 3 times 2 is 6, which is positive. 2 minus 1 is positive, so that's a positive. Okay, let's pick let's pick 1/2. So when you go back and you plug 1/2, 3 times a half is positive. 1/2 minus 1 is negative. Therefore, a positive times a negative is a negative. And now let's pick -1, because we need a number below 0. And you put -1, you get 3 times -1 is negative. -1 minus 1 is negative, and a negative times a negative is a positive. Wonderful. So the signs constantly change, okay? I have to erase this, but you guys can always pause the video. So the signs are going to change, right? So tell me what happens here. Well, f prime is the derivative, and it tells you about the slope of the function, okay? So here, all the way from -infinity to 0, I'm increasing. Then from 0 to 1, I'm decreasing. Then I'm increasing. So I have a maximum. Okay, so I have what we call a relative max at 0 something. And I have a minimum. Remember, I'm coming down and then up. I have a minimum at 1 comma something. How do you find that something? Well, you have to plug it back into the original, okay? So plug 0 back, you get 0. Plug 1 back, you get 1 minus 1.5, which is -1/2. You guys can pause the video, no calculators. So that's how we find the max and the min, okay? F of x equals sine x. Great, let's do the same thing. F prime of x is equal to cosine x. This is going to be so cool because you're going to see, oh wow, doesn't a sine curve look like this? Right? Doesn't it have a max at pi over 2 comma 1? Doesn't it have a min at 3 pi over 2 -1? Now I'm going to prove it using some derivatives. So first, you set the derivative equal to 0 to find the critical number. Now, if you guys remember, where does cosine equal 0? Actually, cosine equals 0 at 90 degrees, then again at 270, and there's many other places. So what we want to do is we want to restrict in our question 0 to 2 pi. We want to restrict our interval. So I'm going to restrict it from 0 to 2 pi. Okay? So right now, cosine equals 0 at pi over 2 and 3 pi over 2 only, okay? Even though it's always pi over 2 plus 180 degrees, but because I restricted my interval to 0 comma 2 pi. It's only these two here. So what am I going to do? I'm going to make an interval. I'm going to put pi over 2. I'm going to put 3 pi over 2. I'm going to put f prime of x, and now I'm going to do something even crazier. I'm going to put a 0 here and a 2 pi here because I'm closing my interval. Okay, so now tell me about cosine. Remember, all students take calculus? All students take calculus. Okay, so we're going to pick a number between 0 and pi over 2. Remember, pi over 2 is 90 degrees, okay? So pick 60 degrees. Is the cosine of 60, I'm plugging it right back into f prime, is the cosine of 60, is that positive or negative? Well, 60 degrees is right here, so that's positive. Between pi over 2 and 3 pi over 2, so that's between 90 degrees and 270, that's 180. So is the cosine of 180, do you guys remember what that is? That's -1, so that's negative. And then 3 pi over 2 to 2 pi, well, that's the fourth quadrant. Cosine's always positive. Okay? And now take a look at the graph, how insane it is. You're telling me that the function increases from 0 to pi over 2. Look at that. You're telling me that the function decreases between pi over 2 and 3 pi over 2. Look at that. It's decreasing. You're telling me that it increases. How amazing it is to use some calculus to show you where the function's increasing and decreasing, okay? Now, we know that if it increases then decreases, that's a max. So our max is at pi over 2. And we know that if it decreases and increases, then there's a min, and that's our min. And then you have to plug it back into the original. Sine of 90 degrees, 1. Sine of 270, -1. This is called our relative max. This is called our relative min. And before I let you guys go, I want to show you what I did here. I restricted. So anyway, how beautiful is that? You guys should all like be wow, wow, wow. Okay, so it's beautiful. I was like mesmerized when I learned this when I was 7 years old. So check this out. I forgot what I was going to say because I'm still mesmerized by it. I closed my interval. When you close your interval, you're supposed to do something. It's called the absolute extrema, okay? So this is not only the relative max and the relative min, this is called the absolute. And I'll tell you why in our next video. So come back, but please enjoy this video. Watch it once or twice. Give me a like, comment.